Hi grade 8. So just before we access the links in the table to practice the work from grade 6 and 7, we'll just have a super quick run through the main highlights from grade 6 and 7 to engage your geometry brains. So when you see terms like complementary and supplementary, what do they mean? Remembering complementary means the two angles add up to 90 degrees. So we might have had one is 60 degrees, and then what is the other? So of course that's 90 minus 60, which is 30. Supplementary was the angles on a straight line. So we all remember, hopefully, angles on a straight line add up to 180. So that was 60 degrees in this case. What would that be? So you'd say 180 degrees minus 60 degrees equals 120. And of course there might be more than one angle making up the angles on the straight line, but they all add up to 180. Okay, so when you start doing the questions on parallel lines, remember that if two parallel lines, these two, are cut by a third line, the blue one, that is called a transversal. And from there, we get angles which are related to each other in certain ways. If you look for an F shape, you might recall, right, that angle equals that angle. So if you see an F shape, they are called corresponding angles. Right, can you remember what other shapes we look for? We can see a Z shape. Okay, it could also be the other way around. So Z shape, you get these angles here, which are equal. And those are called alternate interior angles. However, we also get the exterior. So the x's are equal and these two are equal. So we call them, I'll just do the general term, which is alternate angles, the interior and the exterior. And then finally we get the C shape. I'll use a highlighter, this one. So the x is not equal to that blobby circle, however they are supplementary. Okay, and we call the C shape co-interior. Corresponding or equal, alternate or equal, co-interior add up to 180. Alright, so let's move away from parallel lines for a moment. Alright, so looking at our angles mixture, there's a lot going on here. Vertically opposite angles is when you have two lines that cut each other, they are simply equal to each other if they are opposite to each other in this way. Vertically opposite, we call it. So those two are equal, and we could call these two x, they are equal to each other. Angles around a point or a revolution is exactly what it says. All these angles together add up to 360 degrees, so that allows you to solve problems if they are missing values. Once again, supplementary, complementary, we've looked at them previously. Angles in a triangle always add up to 180. So you might have x 65 degrees, and that looks like a 45 degrees. So what would x be? X would equal, which is 180, take away 110, so x equals 70 degrees. And then you will also have exterior angles of triangles. So this angle here, and there are multiple ways of working that out. Firstly, if x is 70, we know this one must be 110. There's also the rule that tells us the exterior angle equals the sum of the two interior opposite angles, which means that's another way of seeing that it's 110. All right, so let's move into angles in a quadrilateral quickly. Any quadrilateral, no matter what it looks like, the angles, 4 of them, would add up to 360 degrees. So what we've looked at so far is pretty much grade 6 work. Then this part here is what should have been done in grade 7. So if you're new to school this year, there might be gaps or you might be ahead. Anyway, this is what students should have done last year. So surface area of prisms, that basically means taking a prism, a 3D shape that can be cut into slices, and working out the area of the outside. It's a prism because you can cut it into slices that look identical. Okay, cutting it this way. Down here we have a badly drawn cube. Now, to find the surface area of the triangular prism, you would need to work out firstly the area of the triangle this side, and of course there are two of those, one this side and one at the back or other side. And you need to remember the formula for the area of a triangle, so base times height divided by 2, and there are two of those. Then you would need to work out the area of this side, the opposite side, which we can't see, and the underneath. So imagine painting this shape, and you need to find the area required to paint it. That would be your surface area. So that's the same for any prism. In some cases, you will find surface area of 3D shapes that are not prisms, like, for example, a pyramid. Okay, so circles. This is the one area that students do tend to forget the main formulae. So if we have a circle, and that's the center, the outside distance would be called the circumference. The formula for the circumference, C equals pi times the diameter, or 2 times pi times the radius. D for diameter, R for radius. So that's the circumference, to find the distance around the outside. Okay, so what about the area? If we want to find the part that's filling up the circle, one of the most famous formulas, area equals, can we remember? Pi r squared. Okay, so area is pi times the radius again. Okay, very important. So that will help you a lot when you're trying to find the surface area of a cylinder, for example. So let's say this is our cylinder. So you would find the area of the circle at the top, pi r squared. Area of the circle at the bottom, another pi r squared. And then we would fold out this part, which would actually look like a rectangle. You probably would have done that last year. Okay, so finally looking at volume, remember volume is 3 dimensions. So if you're finding let's say the volume of this badly drawn cuboid, you would find the area of the face and simply multiply it by the third dimension, which we can call the length or the height. Okay, so let's say that was 3 centimeters, that was 5 centimeters, and this is 10 centimeters. So the volume is simply 3 times 5 to give you the area multiplied by the 10. Okay, and that is 150 centimeters cubed. Right, so just remember you need to find the area of the cross section and multiply it by the third dimension. So that's why prisms are easy to find volumes, because they are cut into slices. So that would be the same as finding the volume of a cylinder. You just literally find the area of the circle and times it by the third dimension. Or a triangular prism. Find the area of the cross-section of the face and times it by the third dimension. So prisms, volume, super easy. So this was just a very quick look at what we did or should have done in grades 6 and 7. So head on over to the table now. Click on one of the links that you would like to practice. Don't spend all the time in one area. And if you need more explanations, you can contact your teacher, or of course you can also find videos explaining these things. Khan Academy, there's loads on Sparks, of course, Corbett Maths, and of course YouTube.